Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to the second episode of Gardeners of the Galaxy, a new podcast for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore cultivating the cosmos, planting planets and sowing seeds in space. It has been an exciting few weeks for space enthusiasts. We've witnessed the return of Crew Dragon, which splashed down safely carrying 2 NASA astronauts and lots of science samples. And we saw the third launch of the Mars Summer, which I will be talking about a little bit later on. And I'll also be talking about space peppers, the origins of astrobiology, and how many people would be needed to maintain a settlement on Mars. And I've got a giveaway for you, so keep listening for all that and more. In the first episode of the show, I was talking about a NASA plant scientist's kitchen sink experiments to grow moon radishes during lockdown. There's actually an experiment to grow radishes on the International Space Station right now, and it's called Plant Habitat 02. It initially launched to the ISS in February 2020, and I've been trying to keep up to date with it by reading the on-orbit status reports. The radishes are scheduled to grow in the Advanced Plant Habitat, or APH, which is a new growth chamber that can cultivate larger plants than the veggie system. During the first test of the APH in spring 2018, it grew Arabidopsis, a small plant that scientists use as a model, and dwarf wheat. It seems that there have been some issues with the APH because in June and July the ISS crew were trying to replace a faulty environmental control system. It looks as though those efforts have been successful because the latest news is that astronaut Chris Cassidy has been checking the grow lights and this is fascinating, installing an acoustic shield to protect plants from noise on the space station. Isn't that intriguing? Hopefully we'll get more details on that in the future. For now though, the reports are saying that Plant Habitat 02 is waiting for samples to be delivered on the NG-14 supply run, for which the scheduled launch date is currently the 30th of September 2020. And the space station has a new piece of hardware that can be used for plant experiments. For the last couple of months, Chris Cassidy has been installing and configuring the Spectrum system. Spectrum is designed to take fluorescent images of biological specimens, so that could be plants, but it could be anything that will grow in a petri plate. It's equipped with a high-resolution monochrome camera to capture images of fluorescing proteins. During a 12-day growth cycle, it will automatically take photos and transmit them back to Earth. In fact, Spectrum is designed to run with minimal intervention from the crew. Its lighting, carbon dioxide levels and ethylene levels will be monitored by ground crews on Earth. So there's not much for a space gardener to do there. Where's the fun in that? Again, the reports say that the first samples to be analysed in Spectrum will be arriving on NG-14. In the meantime, the system has been powered down. On Thursday the 30th of July, NASA's Perseverance rover launched on its way to Mars. It was the third of 3 missions to blast off in recent weeks, which is why some commentators have dubbed this Mars Summer. Why is there a glut of Mars missions this year? It's because the distance from Earth to Mars varies. The 2 planets have their own orbits around the Sun, and every 26 months or so they come into their closest alignment. Spacecraft that launch during this window have the shortest distance to travel and require the least fuel. It's why the joint European-Russian ExoMars mission, which has had technical issues and wasn't ready to launch this summer, is now delayed until the autumn of 2022. The spacecraft launched this summer still face a long trip and won't arrive at Mars until February 2021. First off the starting block was the United Arab Emirates HOPE mission, which launched from Japan on the 19th of July. HOPE, named Al-Amal in Arabic, is the UAE's first mission to Mars. In fact, it's their first deep space mission of any kind. When it gets to Mars, HOPE will orbit the planet, producing a detailed picture of the atmosphere and weather. It has instruments to study dust, ice clouds, water vapour and temperature in the lower atmosphere, and carbon monoxide, hydrogen and oxygen in the upper atmosphere. The data it collects will be freely shared with the world's scientific community and may help us to understand how Mars lost most of its air and water. The mission is also remarkable because 80% of its science team is female, headed up by Sarah Al-Amiri, who is also the UAE's Minister for Advanced Technology. The probe's arrival at Mars is timed to celebrate the 50th anniversary of the unification of the UAE, which is an alliance of 7 emirates. One of the ideas behind HOPE is that the mission will help to transition the UAE away from an oil-based economy towards a knowledge-based one. The second Mars mission to launch this year was China's Tianwen-1, which means questions to heaven. This is also China's first Mars mission, but they have several successful moon missions under their belt. Tianwen-1 is an ambitious project including an orbiter, a lander and a rover. Now, China isn't as open about their space program as NASA and ESA might be. What we do know is that Tianwen-1 aims to produce a geological map of the planet and to study soil composition and magnetic fields. And the most recent launch, of course, was NASA's Perseverance rover. Visually very similar to the rugged Curiosity rover that's still exploring the Red Planet, Perseverance is equipped with a drill to extract core samples from rocks. It will be able to store its most exciting finds, and NASA's plan is to collect those samples and return them to Earth in a future mission. Perseverance's primary goal is to look for signs that there was life on Mars in the distant past. We're not talking about little green men here, of course, but microbes. The planned landing site is Jezero Crater. Scientists believe this area was once home to an ancient river delta. More than 3.5 billion years ago, the river spilled over the crater wall and created a lake. There's evidence that water carried clay minerals from the surrounding area into the crater lake. If microbial life lived in Jezero during one of its wet periods, Perseverance might be able to find signs of life in the lake bed or shoreline sediments. Perseverance will have a little friend on Mars. Hitching a ride on this mission is Ingenuity, a small experimental helicopter. It's the first time we've attempted powered flight on another planet. Perseverance is also carrying the names of 11 million humans to Mars, mine among them. If you missed out this time, you can sign up now to have your name included in the next Mars mission. I'll put that link in the show notes for you, but you can also just search for Send Your Name to Mars. And the rover carries a small aluminium plate showing Earth on top of a serpent-wrapped rod. That's a nod to the ancient symbol for medicine, and the plate is a tribute to healthcare workers around the world and their tireless work during the COVID-19 pandemic. One last fascinating snippet about NASA's Mars mission. It's returning 2 chunks of the Red Planet. 2 of the rover's instruments, Sherlock and Supercam, will be using Martian meteorites as part of the calibration tests that ensure scientists know they're working properly. One of those 2 meteorites has been residing in the Natural History Museum in London since the year 2000, after being discovered in Oman in 1999. Caroline Smith, who is Principal Curator of Meteorites at the Natural History Museum, explained that while some Martian meteorites are very fragile, this particular one is as tough as old boots. It hasn't seen Mars for between 600 and 700,000 years. And although the meteorite is technically on loan to NASA, it's likely that the Natural History Museum doesn't really expect to get it back. This time last year, NASA announced that a chili pepper would be the first fruit that their astronauts would attempt to grow on the International Space Station. Now that's fruit as a regular person would understand the word. Botanists would point out that the peas that the Russians have been growing in their section of the ISS are also fruits. In 2016, the Russian news agency TASS reported that cosmonauts would be growing sweet peppers in the Larder 2 greenhouse that was due to be delivered in December of that year. However, I have no clue whether they ever did. Jacob Torres is a technical horticultural scientist at NASA's Kennedy Space Center in Florida. He started at NASA in 2018 on an internship. At that point, scientists were investigating whether hatch peppers, which grow in New Mexico's deserts, would be suitable for space cultivation. Torres comes from New Mexico, and he had a different suggestion. Española peppers naturally grow at higher altitudes, and they have a shorter growth cycle. Both of these attributes make them more suited to growing on the space station. Peppers that naturally grow in deserts become quite drought-tolerant, meaning they may well cope better with the issues irrigation poses in microgravity. Space restrictions mean you also have to stick to plants that don't grow too tall. NASA's chillies are scheduled to grow in the advanced plant habitat, which is suited to growing larger plants than the veggie growing system. And there are no bees in space, so you have to pick plants that are self-pollinating or easily hand-pollinated. Oh, and since there are no real cooking facilities on the ISS, you have to pick a crop that the astronauts can eat raw. NASA tested dozens of varieties to find out which peppers would do best in space. The one chosen for the initial experiment is the Española Improved, developed by the New Mexico State University Agricultural Extension. It's a cross between the Hatch Sandia pepper and the traditional Española pepper. Why choose chilies? Well, one of the problems that astronauts face in space is losing their sense of taste. It's thought to be at least partly due to the lack of gravity causing congestion, and it means that space crews go through a lot of hot sauce to spice up their meals. As an interesting aside, astronauts have to be careful about their salt intake, so upping that isn't an option. And both salt and pepper are supplied in liquid form, so no particles end up floating around in the atmosphere. Anyway, after weeks and months of eating processed food, space crews are always thrilled when something fresh is on the menu, particularly if it has a bit of crunch. And peppers are high in vitamin C, which could be a valuable addition to their diet. So the initial report stated that the peppers would be blasting off to the ISS in March 2020. However, I have no confirmation of that happening, so the pandemic may have changed the timescale. In the meantime, Jacob has put together the Space Chili Grower Pepper Challenge as an outreach activity. It's a contest to see who can grow the hottest chili using methods NASA would use to grow peppers in space. Gardeners of the Galaxy will be keeping an eye out to see what happens with that and when there will be chilies in space. I have no doubt we'll come back to that in future episodes. Of course, chilies are also popular here on Earth. Some friends of mine run a nursery in Kent called Victoriana Nursery Gardens. One of the things they specialise in is chili peppers. In a typical year, they run the Challock Chili Festival in the autumn, where visitors can taste chilies and all kinds of chili-laced foods, alongside buying fruits, plants and seeds. Unfortunately, that can't go ahead this year because of COVID-19. Fingers crossed it's back on the calendar for 2021. The lovely people at Victoriana grow over 200 different varieties of chilli, ranging from no heat to the hottest breed in the world. Personally, I am a wuss when it comes to chilli, so I stick to their cool chilies, which are bred to have all of the flavour and none of the heat. The official measure of a chili's heat is the Scoville Heat Unit, SHU. So chilies can range from 0 SHUs right through to over 1 million. Now, it's too late in the growing season here to sow chilli seeds now, but if you're based in the UK and would like to give it a go next year, then Victoriana have given me some seeds to give away. They've given me 6 packets, which I will divide into 2 prizes, one of cool chilies and one slightly hotter. In the cool prize, you'll find KN Sweet at 0 SHUs, Apple Crisp at 400 and Holy Moly at 700. The hotter prize contains Numex Suave Orange, which weighs in at 800 SHUs, together with Numex Centennial, which is classed as a mild chili, somewhere between 1,000 and 5,000 SHUs, and Kashmiri North India, which is a medium chili between 5,000 and 15,000 SHUs. If you have a UK mailing address and you'd like to win some chili seeds, drop an email to earth@spacebotany.uk and let me know if you have a preference for the cool chilies or the spicier ones. The deadline for entries is the 31st of August 2020. Then I'll let Ryan pick the winners' names out of the hat at random. One of the articles that caught my eye recently appeared in the New York Times with the headline, "The Doctor from Nazi Germany and the Search for Life on Mars." I think that most people now realise that the American space programme built on research that started in Nazi Germany. Between the end of World War II and 1959, America had a secret programme called Operation Paperclip, which brought more than 1,600 German scientists, engineers and technicians to the United States to work on government programmes. Wernher von Braun and his V2 rocket team are the most famous examples. Von Braun became an American citizen and was the chief architect of the Saturn V rocket that took the Apollo missions to the moon. Some of the Project Paperclip scientists had links to the Nazi Party, including von Braun. Von Braun and his team joined NASA, but other Project Paperclip scientists worked for the US military. Science historian Jordan Bim unearthed a film clip of Dr. Hubertus Strughold, a professor of space medicine at the Air Force School of Aviation Medicine, and he was working on an experiment called Mars Jars. Mars Jars are a way of recreating conditions on the red planet so that we can do experiments without actually having to go there. They've been used a lot in astrobiology to test whether different organisms could survive life on Mars. Carl Sagan demonstrated Mars Jars during his award-winning television series Cosmos, first broadcast in 1980. Until now, most people thought that he had invented them. The military origins of astrobiology have been hidden from view. This year we have seen Black Lives Matter protests and discussions around statues that commemorate people that are heroes from one perspective and villains from another. One of the things we can do moving forward is to be honest about our history and our historical figures, and to view them in a more nuanced light, and that's as important in science as it is in other walks of life. The New York Times article is fascinating, and you should read it if you can find the time, so I will put a link to that in the show notes for you. In June this year, a French scientist called Jean-Marc Salotti published his mathematical model that suggests you'd need at least 110 people to start a sustainable settlement on Mars. Now, that's a very complex problem to explore and partly depends on what resources the settlers have when they arrive. Salotti concentrates on 2 other factors that will have a considerable effect on survival. The first is the availability of local resources, what NASA calls in situ resource utilisation. How much will the settlers be able to make from the natural resources on Mars? The second factor is the production capacity the Martians have, that is, their ability to actually make use of the resources available. Salotti develops a concept called the sharing factor. Astronauts on the ISS spend a lot of their time maintaining and upgrading the station's systems. There's also housework to do to keep the place sanitary. If you were alone on Mars, like astronaut Mark Watney was on the Martian, you'd spend all of your time on survival. If there are other people with you, they can share the burden of necessary tasks, making it easier to do things like producing water, oxygen, food and power. Although a more substantial settlement would need more of those things, the sharing factor means there's a benefit to having more people. But how many people would be optimal? The equation ultimately comes down to how much time people have and how much time producing life's necessities takes. Slotty's model of balancing that equation on Mars comes out at 110 people. If you want to read the whole report, it's called Minimum Number of Settlers for Survival on Another Planet and was published open access in Nature Scientific Reports. I'll put a link to it in the show notes for you. From Mars to the Moon, and ESA has published a story about some fascinating ongoing research that is producing 3D printed objects from simulated moon dust. This is another example of in-situ resource utilisation. Billy Grunstrom is a Swedish student doing a 6-month internship at ESA's European Astronaut Centre in Germany. Billy will be working in a team that investigates how to use lunar regolith to make bricks and more complex parts for building. They're using their own simulated lunar soil, made from volcanic powder from around Cologne. It's left over from volcanic eruptions around 45 million years ago, and researchers have determined that it's a pretty good match for real moon regolith. Billy's project takes a new approach and uses a bio-based polysaccharide additive that's derived from algae. According to Billy, one day the algae required could be grown in bioreactors on the moon. It could use the carbon dioxide exhaled by humans, plus water and sunlight, creating a fully integrated production system. And speaking of 3D printing, according to Metro, 3D printed vegan steaks could be available at a restaurant near you very soon. Using 3D printing, an Israeli company called Redefine Meat says it has replicated the texture, flavour and appearance of meat. Their alt steak is made from soy and pea proteins, coconut fat, sunflower oil, natural colours and flavours. The company is planning to trial the alt steak in Israeli restaurants this year with a view to rolling it out to European restaurants in 2021 and supermarkets in 2022. The idea of 3D printing food is so space-age that it's hard to imagine ordinary people on Earth tucking in before astronauts, but it seems that's exactly what's going to happen. What do you think? Do you fancy a 3D printed vegan steak? And while we're talking about the future of food, the world's largest urban farm has opened on a Paris rooftop. It's called Nature Urbaine and covers 14,000 square metres, which is the size of 2 football pitches. Its opening was delayed a little by the pandemic, but roughly a third of the available space is planted with lettuces and strawberries. When it's up to full production, 20 staff will be harvesting up to 1,000 kilos a day with maybe 35 different crops. It's all grown using a soil-free method, using a small quantity of water that's enriched with organic nutrients, minerals and bacteria, and pumped around a closed circuit of pipes, towers and trays. The system uses 90% less water than a classic intensive farm for the same yield, and the whole automated process can be monitored and controlled remotely with a tablet. The project is already supplying fruit and veg boxes to local residents, some nearby hotels and a private catering company. Plus there's a bar and restaurant in the garden itself. Now that's all we have time for in this episode. I'll be blasting off with a new payload of intergalactic gardening goodies very soon. In the meantime, you'll find lots more information on growing plants on Earth and beyond on my website, theunconventionalgardener.com, and you can follow me on Twitter at Orbital Gardens. Thanks so much for listening. Goodbye.
Orbital Gardens, this is Mission Control. We are confirming termination of your signal. Unfortunately, we have also lost your movie requests, so we have picked you The Martian and Frozen. Uplink commencing now. Mission Control out.